Well, we consider a question from, that's question 21, and the paper is KCSE 2019, paper 1. So question 21 reads, the heights of 40 athletes in a county athletics competition was shown in the table below. So we have height given in this column, and we see they are given within this range, which is the class intervals, and then the frequency, this column. And here we find that x, this frequency is not given, and so we are asked to find the value of x here. Then state the model class, 1 mark. Calculate the mean height of the athletes, 4 marks. Then calculate the median height, correct 1 decimal place of the athletes, 4 marks. Yeah, and that's the question. So let's see what our solution is. Well, now the question that we want to consider is paper 1, 2019. That is question 21. And as you have seen, the heights of 40 athletes in a country athletes competition were as shown in the table below. So 1, 2, 3, 4, 5, 6. So the table that we have, I want to draw it here. The first column that we have is height. We have height, of course, in centimeters, in centimeters. And then next column we have is that of frequency. Frequency. We denote it as F. We have classes 150, 159, 160, 169, 170 to 179, 180 to 189, 190 to 199, 200 to 209, 209. So that is the frequency column. This requires a ruler to look neat. So let's consider this the frequency column. This is the frequency column. Let me call it frequency column. And we have 2, 8, 10, 2, 8, 10, x, 6, 2. X, 6, 2. Then the question is find the value of x. We need to find this particular value. Find the value of x. So we are told the heights of 40 athletes in a county. So that means that for us to find the value of x, so part A, we will say that summation of the frequencies, that is summing here, we add here, should be 40. If you get the summation here should be 40 if you add them. So if summation is 40, therefore x will be summation of f, which is 40, minus summation, of course this is also f, but now we add 10, 20, 26, 28, so minus 28, and that gives us the value. So 40 minus 28, we get the value 12. So x is 12. X is 12. So that's the first. That is the first. Value that we get, and so we can substitute it here. We can then put it here, or we just leave it as such so that it's seen. But then we see x is 12. We already found it. So the next question is, state the model class. State the model class. Now, the model class has to be that class with the highest frequency. So if you want to get the model class, then you look at the class that has the highest frequency. If we check along the frequency column, we see that at 12. So it means that the model class is 180 to 189. So part B, if that is part B, that is part B, yes, part B, we say 180 to 189 is the model class, is the model class, is the model class. Then we are asked, calculate the mean height of the athletes. Mean height of the athletes, that's now part C, Roman 1. Part C, Roman 1, the mean height of the athletes. Now, mean height should be summation of F over N. Summation of Fx. Fx now. Summation of Fx over N. That is what should give us the mean. The mean of the athletes. That's what should give us the mean of the athletes. So, but what's our X? So we'll come here and define what we refer to as the midpoint. For us to define X, we need the midpoint here, because this is a class interval. So I will come here and say I need the midpoint. By using the midpoint, I'm simply distributing the weight. The weight to be actually I'm averaging in that particular class interval. I'm distributing the weight towards the center, towards the average. So that's the mean. That's actually the argument behind getting the midpoint. So add this plus this, divide by 2, you should get 154.5. Add this plus this, divide by 2, then you should get 164.5, 174.5, 184.5, 194.5, 204.5. Those are excess. Those are now excess. These are excess. So this is X. So that's what we have. Those are now values of X. Those are now values of X. Those are values of X. So the next assignment is, because I need Fx, is then to form an Fx column here. To mean I'm multiplying this by this, this by this, this by that, that throughout. So 2 times this should give me 309. 8 times 164.5 should give me 1316. The next should give me 1745, 2214, 1167, 1167, 1167, then 49, 409, 409 as such. So we need to add all this and plug them here. So if you add this, if you add everything, this to this to that to that to that to that, you should use your calculator to confirm that. But the value you should be getting is 7160. That's the value that you should be getting, and then that should imply that our mean then will be 7160 divided by 40, and that is about 179. Yes, that's about 179. So we have 179 centimeter. That's the mean. Okay. Roman 2 is asking us to find the median height correct to 1 decimal place of the athletes. The median height correct to 1 decimal place of the athlete. So for us to get the median, there is a column that we'll need to add. We'll need to add a column for cumulative frequency so that we are able to identify exactly where our median height will be found. So for that reason, I'll get cumulative frequency here. I call it CF. We call it CF. So it's 2 here. 2 plus 8 is 10, 20, 32, 38, 40. That's what we have. 38, 40. But then we can also have what we refer to as the upper class boundary. So if we have the upper class boundary, I want to refer to it as UCB, upper class boundary. That becomes the upper class boundary, which is 159.5. Here we have 169.5. It goes like that because we take this, then 179.5, 189.5, 199.5. Then we have 209.5. So we take this 209.5. That's what we have. So for us to get the mean height of this particular group, then first of all we'll say that median. So Roman 2. We'll say that median is equal to the upper class boundary. It will be the upper class boundary Okay, let me just write it first, then I'll explain. So it will be 169.5 plus 20 minus 10 over 10 times 10 times 10. So what we have here is that first what we need to do is to identify this one is the upper class boundary of this particular class. This class here. This is the upper class boundary of this particular class. But it is the lower class boundary of this class which contains the median. So what we do, first of all, to know which class contains the median, we'll have to divide 40 by 2. And if we divide 40 by 2, then we check what corresponds to the 20th athlete, because 40 divided by 2 is 20. So dividing 40 by 2, we get 20. And if we check under the cumulative frequency column, we find 20 here. And if we find 20 here, then what we write here is the lower class boundary of that particular class that contains the median. So the lower class boundary here is 169.5, and that happens to be the upper class boundary here. So that is what that 169.5. That's how we get it. Is the lower class boundary of the class containing the median. And then this 20 is the cumulative frequency corresponding to that class that contains the median class. 10 is the frequency of that particular class. 10 is the frequency of that particular class that contains the median. And then that 10, we divide, okay, it is 20 minus 10 over 10. So this 10 here, if you look at what we refer to as the class width, you'll see that it is 10. So we subtract 150 from 160, you get 10. Subtract 160 from 170, you get 10. It's across, it's throughout. So that's why we end up with this, and this should give us, if you work that out, the value that you should get is around 179.5 centimeter. You should get around 179.5 centimeter. So that is what you are expected to do. So the main task here was having to figure out how you fill this table. Once you fill in this table, it is possible to get your mean, it is possible to get your median, and if you go ahead slightly by defining what x squared column would be, then you are able again to consider to get values that correspond to standard deviation, which when squared gives you the variance. So we stop there. If there's a question you have, please leave a comment in the comment section, and I will respond to you. So up to now, meet you in the next video.